All right, welcome back. Week 1, Intro to Programming for Business Majors. This is the third video we're making here, so let's go ahead and pop over to our slide deck. In the program process, you need to clearly define what a program is to do, visualize the program running on the computer, and use design tools to create a model of the program. Check the model for logical errors. Enter code and compile it. Correct any errors during compilation. Repeat steps 5 and 6 as many times as necessary. Run the program to test data for input. Correct any runtime errors while running the program. Repeat steps 5 through 8 many times as necessary. Validate the results of the program. Software engineering encompasses the whole process of crafting computer software. Software engineers perform several tasks in developing of complex software projects, from designing, writing, testing, debugging, documenting, modifying, and maintaining. And when it comes to these large, massive programs, you normally only work on a small part at a time. It's kind of like going to an assembly line for a car. This one person that puts the brake calipers on doesn't also put the pistons in your engine. They've all got specialized jobs. Okay, software engineers develop specific programs, diagrams of screen output, diagrams representing the program components, pseudocode, and examples of expected input and desired output. So, this is kind of in the development stage. You'll draw up all this kind of like scratch paper type stuff. Software engineers also use special software design for testing programs. Most commercial software applications are very large and complex. Usually a team of programmers, not a single individual, develops them. Program requirements are thoroughly analyzed and divided into subtasks, which are handled by teams or individuals within a team. Procedural programming. Older programming languages were procedural. Procedure is a set of programming language statements that together perform a specific task. Procedural typically operate on data items that are separate from procedures. In a procedural program, the data items are commonly passed from one procedure to another. The procedural programming programs are developed to operate on the program's data. The data in the program tends to be global to the entire programming, and data formats might change, and thus procedures that operate on the data must also change. So that's procedural programming. Object-oriented. Now, we're going to go over this really briefly, and then we will get deeper into this later in class because it's a hard concept kind of grasp. But object-oriented program is focused on creating objects rather than just procedures. Objects are a melding of data and procedures that manipulate the data. So with object-oriented, objects honestly are kind of mini programs all to themselves. So it's the idea of taking like a procedural type step program. Like let's just imagine the procedure is a calculator. I'm going to send you two numbers and I want them to either add, subtract, divide, or multiply based on what I tell you to do. So if I want to do that, I would have to write in a procedural way, I would have to write it for each one to do. I'd have to write a different procedure for add, different subtract. So with an object-oriented, I can write one like little program, and it takes the inputs of the numbers I give it and the indicator. I give it a plus, a minus, whatever it is, and it does it all in one shot. So that's the best way I can try to describe what object-oriented programming until we get into it later as you start to actually program. But from having no programming experience, it's almost impossible to try to explain object-oriented programming. But the data in the objects are known as attributes, and the procedures in the objects are known as methods. And not that this will mean much to you, but if you want to go up here and look at the little snippet of code we had here, this is an object. This is a class. This is a method of that class, and this is a method of that class. So what's happening is when I tell the computer to print here, it actually sends my information back to this system program, and this program is what tells my computer how to print. Because otherwise, you would have to write, I want it to the screen, all these other things you have to do. It's all there in this class. So that's object-oriented programming. So for objects, again, this graph, I just can't imagine means a whole lot to people who aren't programmers yet. But as we get later in the class, this will make more sense to you. You have your object, you have your attributes, your data, and then you have your methods. Object-oriented programming combines data via encapsulation, data hiding. That means that the data is not exposed to the entire program. And how much that means to you right now, probably not much, but we'll get deeper into that. Only an object's method should be available directly to manipulate its attributes. Other objects are allowed to manipulate an object's attributes via the object's methods. The indirect access is known as a programming interface. So, in non-geek speak, what they're trying to say is, there's a great programming interface out there. You guys might have heard of this term. I'm just going to create a new slide so you can see this. It's called where is my, there we go, text box. Okay, so might have heard something called an API. And it just stands for Application Programming Interface. All right, so what this is, it allows you to talk to another program or an object or something like that. And in the outside world, like a very popular one I use is the Twitter API. What this allows me to do is write a program that I can tell it, hey, I want the last 5,000 tweets that mention what's going on. We've got the, last 5,000 tweets that mention the election. Luckily, there's not one going on right now, but, in America. So I don't actually have to know anything about how Twitter is written. I don't have to know anything about what goes on in the back, what's the name of the variables, what's the name of the programming. All I have to use is this API, which is this interface, and I tell it, send me this. It takes that information, sends it to the object that sits inside the Twitter program. It translates my message, sends me back the results through the API. So that's how this interface kind of works. It's the idea that you can kind of be blind to how the rest of the program works. I kind of say it's like with a car. You don't need to know how the internal combustion engine works to drive a car. You get in, you turn the key, or you push the button, you step on the gas, and it goes. That's your interface. That's your programming interface. Your gear shift, your steering wheel. Those are all interfaces. I don't know how people actually know how. If you had to take apart the whole steering system of a car, it's a lot more complicated than you might think. But so the wheel is your interface. That same thing about programming. So just think about these types of things. We'll get deeper into the class. We're not going to get too deep because it's still an introductory class, but we'll try to explain it and clear it up a little bit later for you. I know this first class was a lot of information. A lot of it's very lightweight information. You don't have to worry about too much, but thank you for sticking with me, and I will look forward to seeing you next class.